Hey guys, it's field trip week. Woohoo! I'm coming at you live from the Houston Museum of Natural Science. Just kidding. I'm really in my kitchen. But isn't it so cool that with technology, it can look like I'm standing right next to this giant dinosaur? So awesome. I'm so excited that we get to go on a virtual field trip this week. It's going to be so much fun. We're continuing our learning about fossils and we're just really going to connect that to all the awesome things that we can learn about at the museum from their dinosaur exhibit. And so we're going to take a look at some of the different fossils and the clues that they can give us into the ancient animals that lived so long ago. And then we're going to give you guys a link that you can go and explore the museum virtually on your own as well. And, some cool things. I know we're bummed we can't go in person, but hey, we can spend all week at the museum now instead of just one day. Which, hey, that's pretty awesome. And also, your whole family is invited on this virtual field trip. Your parents, your siblings, grandma, grandpa, whoever lives with you at home, bring them along with, and they can learn with you as well, which that's an opportunity as well we wouldn't normally get. So still awesome, fun learning that we get to enjoy, and I'm glad we get to all do this together. All right, I'm going to pull myself off of here so I can pull up our awesome fossils here. All right, so the way the dinosaur exhibit is set up at the museum is they kind of start with the oldest, most ancient fossils that they found, and then they gradually move through. So we'll get to the big, exciting dinosaurs at the end here. But we're going to start with a very small organism that was actually called a trilobite, and that's what you're looking at here. This isn't actually a fossil. This is actually a model of what they believe the trilobite would have looked like. And so it was a very small ancient organism, kind of related to the shrimp and crawfish family that we know of today. It's not an organism that is still living today, but scientists know that it was an animal that existed, and they know a lot about it from the fossils that they found. And so remember that a fossil is not the actual dead plant or animal, but it's an imprint that was left in like a rock or something. That they can then determine a lot about what that organism looked like, what it ate, what kind of adaptations it had, where it lived, the type of ecosystem that it lived in. And so just looking at this model here of a trilobite, we can think, this probably lived in an ocean or a sea. We can see that it's designed to be swimming through the water. It's got that flexible body, lots of fins to help it move around. We can see that its eyes are kind of out to the side to look out for predators. And so what this description is telling us about here is about a predator that was out to catch and eat the trilobites. And so that animal is not actually pictured here, but they do know that the trilobites had some defenses towards it with its hard shell body, which we can see depicted here. Its little claws to kind of help pull it away. And so the question is kind of like, well, how did other organisms eat the trilobite? And well, they think maybe they had even sharper claws or teeth that were able to rip through that strong shell. One thing they note at the end there is that they do know that something was eating the trilobites, because when they found fossil feces, which, yeah, I know that sounds gross, but yes, fossilized poop is a real thing. And in those, you can tell what an animal ate by looking at its poop. As gross as that sounds, that's something that scientists do check for. And they found that there were a lot of broken up trilobite bits in this fossilized feces. And so they know something was eating the trilobites. Do they know for sure? No, because of course it happened so long ago. But fossils are really their clue into predicting and thinking about what the world was like thousands and thousands of years ago, which is a super cool feature of fossils. All right, so moving along here. All right, so next we're going to start taking a look at ancient amphibians. And so what we have pictured here is a Permian predator called an Europus. And so This is an ancient amphibian. A modern day amphibian would be like a frog. And so we know that frogs nowadays are able to hear, they're able to process sounds and understand what they're hearing. But interestingly enough, the very earliest amphibians they know were actually deaf, and there was no way for them to hear. And then eventually, scientists know, again, from clues they found in fossils, that sounds were starting to be made. And that because sounds were starting to be made, they know then that amphibians were starting to be able to hear. Because if you're deaf, of course, an animal is not necessarily going to make a sound to communicate. It's going to communicate in a different way. But if sounds are being produced, then they then can conclude that those amphibians were able to hear. And so, if you want to pause the video and read through all of this, you certainly can. But just to kind of give you an idea of how they determined that they were able to start hearing, if you look on the right-hand side of this column here. So a modern day frog skull, when scientists look at that, they can see that there's a big notch behind the eye socket where the eardrum would fit. And then attached to that eardrum is a thin bone rod. And that's their proof that there's a connection from the outside, the sounds transferring in and then going to the brain of the frog to process those sounds. And what we have here, this is a fossil skull of this ancient amphibian. And what they analyze from here is that their middle ear bone is a lot heavier than a modern day frog's, but it's still lighter than amphibians would be even older than its hearing equipment, which makes them conclude that this is one of the first amphibians that was able to start hearing sound. Now, could they hear every sound as well as like a modern day amphibian? No, but they can see that from the way the ear bone and eardrum is developed, that it's able to at least hear some sound. So pretty cool that they could determine all of that just by looking at some fossils and bones. Okay, moving right along, we're starting to dive into Earth's first great plant eaters, which of course we remember that plant eaters are a type of consumer in our food chain or food web. And we know that consumers that eat only plants and vegetables are classified as herbivores. And so an interesting part of this here, again, this is not actually a fossil, but this would be a model that scientists built based on the fossils and bones that they have dug up and found. And so eating plants is actually a very tough adaptive challenge. And it's actually more advanced than you might think. In the sense that the animal has to have a very advanced digestive system in order to digest plants. Plants are actually harder for the digestive system to break down than meat. And so one feature they look for to know when they were starting to eat only plants is that the animal would need very big, strong molar teeth with lots of sharp edges so that they could break apart the tough leaves and then break them down and chew them down in their mouths before they swallowed them. And so that's kind of what's being described here. Another part of it too is that because they were low to the ground, they were able to get plants. They had shovel-like claws that would allow them to dig into the ground to get different roots and other vegetables that may be found in the ground. And so it's definitely another very cool insight that's based solely on fossils that scientists have found. Okay, now we're gonna get into some more of the exciting animals. And so these are fossilized bones of one of the world's first saber tooths. And you can see right here the big saber teeth. Okay. And so the true saber teeth, they believe, evolved about 220 million years before the actual first saber-toothed cats. And so, that's a long time of course, to develop here. And so you can see here that their upper fangs were actually quite a bit longer than the lower ones. Um, and that they were able to really open their mouths quite wide. And they actually used these upper teeth almost like a sword to slash their prey. So you can kind of imagine how that would have gone. You can also see here that it had quite a long neck. This neck really helped give it a lot of power as a predator. And the neck muscles were so strong they could swing their entire neck and head down during the attack. So, not the animal you'd really want to come across in the wild. Now, not all of them were super big. Some gorgons were as small as badgers. Badgers are quite small animals. Think larger than kind of like a cat size or a raccoon. Some of them, though, were as big as polar bears. So they definitely ranged a lot in size. And again, those are clues that, and scientists know they ranged in size based on bones and fossils that they have discovered and dug up over the years. They do know they were all pure carnivores, meaning that they only ate other animals for food. One conclusion with that is, unlike our herbivores that we just talked about, these animals had no molar-like teeth. Remember, molars are more the flat, wide teeth that are used to grind down plants. So carnivores usually lack those teeth. They just have more of the sharp, pointy teeth. That's why, like, we as humans, we are omnivores. We eat both plants and animals, so we have a mixture of kinds of teeth. So again, you can really learn a lot about an organism based on what kind of teeth it has or doesn't have. And so eventually these animals did become extinct as the world progressed. All right, so let's take a look at our next one here. Okay, so this here is an example of a fossil of a crocodile. So this is probably the best example of what a fossil would truly look like. And you can see once they discover a fossil, they actually have to cut all the way around it because they don't want to, of course, damage the fossil in any way, and they want to keep it all together as one here. And so you can see here that it says today some crocodile species, especially the famous Australian salties, still swim through the surf and travel to faraway islands. However, even saltwater crocs spend most of their time along lakes and rivers where they feed and build their nests. Jurassic sea crocs were much more adventurous. They hunted far out in the open waters. So this is an example of that kind of ancient crocodile. Okay, so here's the cool part. How do we know? Okay, how do scientists know that they ventured so much further out into the water, right? Because obviously these animals are not still living. They can't still observe them. And we only know the modern day crocodiles that we can observe that are alive right now. Okay, so here's how they know. So fossil Dinosaur skeletons have been found in Central Europe in the fine, dark mud at the bottom of the holes made in ocean. Nearly all the other fossils found there are from creatures of the ocean, such as coiled ammonoid sea lilies and squid-like belemnites. So sometimes the clues that you learn from a fossil are not even from that fossil itself, but they're found from what other fossils can you find near that fossil and within the same layer of dirt or clay. Because remember, the farther you dig deep down into the earth, the older that fossil is. And so in order for it to be a clue as to what the environment was like for this crocodile, it would have to be a fossil that was found on the same time period, right? That was alive at the same time. Okay, so because they found all these other fossils from organisms that would live way out in the ocean, they can conclude then that these crocodiles also ventured far out into the ocean. Okay. Other clues. So the Stenosaurus's body shape shows a high degree of commitment to ocean life. Normal crocodiles, which they're talking about like modern day crocodiles that we know of right now, have long, strong front legs and can run at high speeds on dry land. These sea crocodiles have smaller, weaker front legs. So here's their front legs here. So you can see they're pretty small and they're not very strong. And so they're not good for walking, but they would be excellent for steering while swimming, right? Because think about when you're swimming in the water, you're a little more weightless, right? The water is carrying your weight, and so it would allow them to just flow through the water. The Stenosaurus's underwater propulsion comes from its thick, muscular tail. So you can see it's got a really long, thick tail here. And so when the animal switched its tail back and forth, it was propelled forward. And to back up, the sea crocodile would use its large hind feet. These are the hind feet here to help it turn around. So a couple things, though, that it does present that our current crocodiles have is that it had an armored plate on its back and belly. So we think the armor must have protected the crocodile from shark bites and from injury during crocodile on crocodile violence. So again, an additional protection that it had. But so cool that all of this information can be gathered simply from looking at this fossil. Just really awesome. All right, now we're getting into the real dinosaurs. I know everyone's like, where are they coming? All right, so we've got a Triceratops here. And we know from these fossils and bones that the Triceratops is the world's #1 favorite vegisaur. Raise your hand if it's your favorite. It was definitely one of my favorites when I was a kid, and still to this day. Interestingly enough, it is also one of the most dangerous land herbivores to have ever evolved. It's certainly, when we look at this is not what you would picture when you mention a plant eater, right? So paleontologists thought we knew all there was to know about Triceratops, but this particular specimen, known as Lane, made us reevaluate everything. So Lane is named for a member of the family that owns the ranch where this mummy was dug. Lane is an excellent skeleton with some of the best Triceratops feet ever discovered. The giant hind paw spread its 4 toes widely to give maximum traction on soft, gooey ground. The forepaw was 5-toed and wide, too. No doubt about it, Triceratops was a mudder, a beast designed to tromp across swamps and bogs. Okay, so it was able to just run at high speeds through really muddy, wet water and soil. Lane's torso was ultra compact and short front to back. The barrel-shaped rib cage, so you can see it's kind of like a big barrel here, expanded sideways in the abdomen to hold a very large gut. So basically, it could eat a lot and it could hold a lot of food. For a dinosaur, Triceratops carried a tiny tail that curled down from the hips. No other clan of dinosaurs had reduced their rear appendage to such an extreme. And you can see right, they're talking about the tail here. So the tail is really quite short in comparison to other dinosaurs. That posed a locomotive challenge, so that meaning a movement challenge. In most dinosaurs, the biggest muscle that attached to the thigh came from the tail. So a wide, long tail was necessary for powerful movement. And so they're saying the Triceratops actually lacked that. A Triceratops would be at a disadvantage unless an alternative muscle developed. So if you look at the lower rear hip bone, it should be back here, it is unusually strong and curves down. There is a muscle attached here that helps that attaches to the thigh. And so they're concluding that this Triceratops developed an especially thick muscle here to compensate for not having as strong of a tail. But definitely such a cool dinosaur, and such a cool example too of the fact that scientists are constantly learning and updating their theories and what they're learning about these dinosaurs as they discover more and more fossils. All right, we've come to the T-Rex. So cool. So this example of this T-Rex here, they named Bucky. And it is a girl T-Rex. So this was originally excavated in 2001 and 2002. And you can see how large it is here, compared to the people standing here, just massive. It took them a really long time to completely excavate because, of course, they have to be really careful when they're digging up these bones. And the skeleton was actually scattered over approximately 2,000 square meters, which is a massive amount of land, and buried under as much as 10 meters of soil, like 10 meters going down. So they had to dig a lot and they had to be very careful while they were digging. But one of the really cool features about this is that Bucky has almost a complete vertebral column to the end of the pelvis. So basically, like its spinal cord here up here. And it's the third most complete tail of any T-Rex known. They also found most of the bones from the rib cage, and just a really, really great example of what these animals would have looked like. One really cool thing is that they found from all these fossils that a T-Rex actually had a very advanced sense of smell. They actually call it the five-ton bloodhound. To the point that they said if a T-Rex was blindfolded on a moonless night, so super dark, it could still locate a person from a mile away simply by your scent. What? Yeah, definitely wouldn't want to be running into a T-Rex anytime soon. Here's how they know its scent was so strong, which is the really cool part, right? The fossils behind it. So they know that their scent was so strong by x-raying the inside of the skull. And they could tell that the sensory parts of the brain and the nerves that would go to and from the brain to communicate to the brain were just massive and really quite complex. And so with its sight, the nerves from the eyeballs were really large. So that tells them that they had really good vision. They could see really well. As far as hearing goes, the sensory canals in the inner ear were medium sized. So hearing was good for most sounds, but it really wouldn't have been able to hear high pitched sounds. So hearing was definitely not its strongest sense. And then, of course, we come to smell. And this is where the Tyrannosaurus Rex just really excelled compared to other dinosaurs. So the nerves that were coming from the part of the nose that would pick up smell were absolutely enormous. They say that a T-Rex has a sense of smell better than 24 bloodhounds combined. Wow, that is incredible. And if it were alive today, a T-Rex could probably be trained to recognize 1,000 different people with just one whiff. Wow. Incredible, incredible dinosaurs. And so cool that with the scientists' use of, by looking at their fossils and bones, that they could learn so much about these ancient organisms. Okay, so here's the next part. You can't actually click on here. It's actually in your back, like where you clicked on the link for this video, but I just kind of want to show you in here and how to get there. So when you click on this, it's going to take you here, okay? And so the Google Arts and Cultural website, and this little icon right here is what you want to click on so you can virtually feel like you are at the museum. So when I click on this little guy right here, okay, and this is what's so cool. Okay, so you can actually now click and drag, oops, I want to go there. And drag around the museum as if you were walking through the dinosaur exhibit. So just super cool. Play around with it, explore with your families, make some scientific notes of the different things that you're seeing. There's our Triceratops and T-Rex. So have some fun with that. There's a bunch of different options to scroll through as well. You don't have to stay in the dinosaur exhibit. Check out some of the different parts of the museum as well. We certainly wouldn't have just stayed in the dinosaur exhibit if we were visiting it in person. So spend as much time as you want in here. Don't forget to go to the last step in your learning when you are done, so you can kind of reflect on some of the things that you learned. Bring it back to me now. All right, but I hope you guys had a great time on the guided part of our museum tour, and I hope you enjoy the rest of your field trip this week. And don't forget to share with your teachers pictures of your virtual field trip and your fun with your families while you're learning. We can't wait to hear all about it. Bye, guys.